because it's a lot of vocab.
That's how weeks work.
No.
Okay. All right, let's get focused. So chapter 22 is about probability, and I do have to say, like, most of what we're going to talk about, I think you already figured out through doing your investigations yesterday. Now I do have the materials for the investigations. Please don't take them. We had a die go missing for a few minutes, and I freaked out. So we got them all back. We're going to go over some vocab just about probability in general, and then we'll go over some vocab that's specific to experimental probability, which is today's section, and that is what you guys worked on yesterday, was that experimental probability. We will have a stat box that we'll come back to. Now, if you know some of these words, you don't necessarily have to write them all down. And like I said, a lot of them we ended up talking about throughout the investigation yesterday. And so we should be able to kind of breeze by some of it pretty quickly. So probability is the chance or likelihood that an event will occur. How likely is it that whatever is going to happen? Now we can write probability as a fraction, as a percent, but if we write it as a decimal, then it's a number that's somewhere between 0 and 1. So if we take that fraction and divide it out before we turn it into a percent, it'll be a number between 0 and 1. For me, probability is something that I think about on a daily basis, mainly because I constantly check the weather and see how likely it is it's going to rain. So I'm like always looking at that. I don't really like the rain. So an impossible event would be something that has a 0% chance of happening. If there is no way that it could happen, then you would have an impossible event, and the probability would be 0. Like, what's the probability that I would drive without my glasses? 0, because I can't see. That's not ever going to happen. Without corrective eyewear. But actually, my contacts, I can't like really see out of one eye. I did try driving in them, and it wasn't that great. So then a certain event is something that there's 100% chance of it happening. So that would be a probability of 1. So that would be a certain event. Experimental probability and theoretical probability are like the two different main types of probability. Now we're going to talk about independent events and dependent events and all sorts of different diagrams for how we can figure out probability and stuff like that as we move forward. But we do need to know the difference between the two types. So experimental probability is based on the results of an experiment. That's what you did yesterday. When you were tossing tacks, you were, it was an experiment. Or when you were flipping a coin, that's a better one. How many of you guys finished the first coin flipping one, where you had to flip a coin 40 times? How many of you guys got exactly 20 and 20? So one of you did, a few of you got exactly 20 and 20. That's more like theoretical, because theoretical we would be using arguments of symmetry. So we would think, okay, because it's equally likely that there's a heads or a tails, you should get 20 and 20. So what should happen is theoretical, but experimental is what actually happened. So sometimes they match up, like we had 3 people that had exactly 20 and 20, and the theoretical and experimental were the same. But then sometimes they're different. So that's the difference between experimental and theoretical. Theoretical is what should happen, should happen 50-50. Experimental is what actually happens when you actually do the thing, whatever it is. Any confusion here? Now, most of these words did come up yesterday in the investigation, so, write down what you need to. I like to keep the notes, for people that are gone. The number of trials is the total number of times the experiment is repeated. So if we go back to the tack example, you had to toss the tacks 80 times. The number of trials is 80. The outcomes are the different possible results for one trial. So when we were tossing the tacks, the different things that could happen, I could have it, if I toss those two tacks, they both could land on their back, they both could land on their side, or we could have one back and one side. So the outcomes are just the different possible things that could happen. We'll talk more about this tomorrow when we get into sample spaces. We'll get some like diagrams and way to figure it out, but otherwise, like what we did yesterday was we just listed what could happen. We could have, those different outcomes. Yesterday, you guys made a frequency table, and so the frequency, if you recall, is the number of times a particular outcome happened. So the number of times we got two backs, the number of times we landed on heads, the number of times whatever happens. And then that relative frequency is the frequency expressed as a fraction or percentage of the total number of trials. So you've got the frequency on top and then the number of trials in the denominator. So you've got a fraction or a decimal, and that's the same way we would calculate probability. The relative frequency and the probability are kind of calculated the same way. So just a little bit on notation. When we are talking about probability, we use a capital P, and then in parentheses we put whatever it is you're looking for. So if we were looking for the probability that we have it land, like our tacks land on both on the back, it would be the probability of two backs. That P stands for probability. So another example, if we're talking about coins, the probability that a coin will land on tails will be notated as capital P, parentheses, tails. So if you're looking, whatever you're looking for, whatever you're looking at, you put in the parentheses. And so, you'll have a lot of different types of probabilities. So maybe it's the probability that a spinner lands on a certain color or a certain number or a certain letter or something like that. So whatever it is goes in the parentheses. Have you ever seen that notation for probability before? I just wasn't quite sure, so I wanted to make sure we touched on that. And then the reason why for the TAC investigation we wanted you guys to combine your results was that the more trials we do, the more confident we are with the estimate. If I just toss those TACs 3 times, that's not going to give me a very good estimate of what could happen, but by combining, 5 different people, we can get more and have a more confident estimate for our probability. So, quick example here. I feel like this might even be overkill since we had the investigation yesterday, but just to quickly go over these vocab words. For this example, a nickel is tossed 10 times. Not very much. This is not going to be very accurate. We're not so confident. It lands on tails 6 times, and it lands on heads 4 times. So what's the number of trials? What are the outcomes? What could happen when we flip a coin? We could have tails, and we could have heads. So those are the outcomes. What are the frequencies? What's the frequency of tails? The frequency of heads? So then for relative frequencies, we would take that number over the total number of trials. So for tails, that'd be 6 over 10. Always simplify. Absolutely always simplify. So that would be 3/5. Or if we want to go to a decimal, we can. You'll notice in the back of the book, they kind of change it up. Like sometimes the back of the book gives decimals, sometimes they give fractions. So I can definitely see benefits to both of those. So it's 0.6. So either way. For heads, 4 over 10 is 2/5, which would be 0.4. So like we said, the numbers for our probability are between 0 and 1. So 0.6 and 0.4 are between those as well. You guys feeling pretty confident about experimental probability? So the last example wasn't really a great example for this, but how many significant figures should you use when calculating the relative frequency? So if you're going the decimal route, how many sig figs should you use? 3. I want to stick with 3, but people tend to forget that. So again, you leave it like a fraction. I'm not saying you have to do a decimal, but here's the thing. If you do a decimal, I need it in 3 sig figs. If you do a fraction, I need it to be simplified. If you do a percent, it should also be 3 sig figs. So the assignment is really not terribly long. I know it says all, it's 4 problems. I know some do have multiple parts to it, but it really shouldn't take you too long. I have the tacks, the dice, the pennies, so if you want to work on the investigation. Did you guys catch the announcement I put in the Google Classroom about investigation 3? You do not have to do the whole thing on investigation 3. As we kept going throughout the day, we realized that we don't want you to do all of it. We want you just to do parts 1 through 4 on the dice one, okay? So maybe I should write this up here. So from yesterday, so investigation 1, 2, and 3, but 3 only do parts 1 through 4. Let me know when you get the investigation done. Like if you don't have time to get it done this week, if you need to use my materials next week, that should be fine. I have one last tip from an article I read today. How many of you guys feel like you have trouble remembering things? Like math things. Like you're like, oh, we did that 2 weeks ago, I can't remember. So this is what I read. I read this article in the Washington Post that said that multitasking makes our brains tired. Like we get cognitive fatigue. So we tire out thinking when we multitask because like I don't know about you, when I'm like trying to grade your papers, all of a sudden there's something on my phone, I get a notification, I get a text message, so I look at that, or I play with my cat, or I get distracted and I'm like, I need a snack now. But so what happens is that we get distracted and we don't form good memories. So I'm gonna call it out. Those of you on your phones, the reason why you can't remember what I'm saying is you're not forming the memories because you're not focused because you're looking at your phone. So you're like, your brain's not forming the right memories. So no kidding, no wonder you don't remember it. Seriously, that's what it said in the article. Just putting that out there. Food for thought.